Hello and welcome to another one of Dee's ADD videos. Today we're going to look at this beginner example of a linear function using the epsilon delta definition for limits to verify that indeed when we take the limit as x approaches 1 we do get a -2. So the goal here is to use the definition to try to establish a relationship between epsilon and delta. We want delta equals some epsilon over k. The first step is always state the definition. You don't have to use symbols like I did. You can look up these symbols on my symbols handout or watch the video if you want. But this is if the limit as x approaches c of some function f of x equals some limit answer L, then for every epsilon greater than 0, there exists a delta greater than 0 such that f of x minus L absolute value is less than epsilon whenever 0 is less than absolute value of x minus c is less than delta. The first question on the quiz every semester for my students will be state the definition. You don't have to do it like this. You can write it out in words if you want, but make sure you do know it. The next step will be to apply the definition. So we got to plug in our function and what our limit approaches to this definition. So f of x is 4x minus 6, the function. The limit is -2, so minus the limit is less than epsilon, and then our c value is 1. So that's why we have a 1 is less than delta. Notice I did drop the greater than 0 or less than 0 part, depending on your perspective, left to right. Here, this is talking about deleted neighborhoods. You don't have to worry about that till you take a class called Theoretical Concepts of Calculus. That is, if you have to take it as a math major, you probably do. But most people aren't math majors, so let's not worry about deleted neighborhoods for now. When you're doing the definition, all you can need is the x minus c. So the goal now is to make this look like the x minus c. So when we simplify here, you'll see that what happens when we combine these two negatives multiplied to a positive, then these are different, so you take the difference and keep the sign of the larger. And then you notice there's a 4 common in both of these. You factor out the 4 and you see that the x minus 1 is x minus c. So divide both sides by 4, and now you can compare these two. So compare the x minus c value to what you just evaluated, and you will notice that x minus c are the same to the left of the inequality, right? So this is x minus 1, this is x minus 1. So if they're the same on the left side, then whatever's on the right side must also be the same. So delta equals epsilon over 4. And that right there is what you want. You want an established relationship between delta and epsilon. Sometimes they'll give you what epsilon is. If they do, just plug and chug, go from there. But the goal is to establish this relationship. Plug in your function, simplify, make the f of x minus L look like your x minus c, and then put it in this form. It does get a little trickier with trig functions, infinite limits. Sometimes you got to think outside the box. Check out the intermediate and advanced videos, again, for best results. Pause them first, and then look at the solution. Try to solve them before you see the answer. Practice, 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 and as always, have a great day.